Hello everyone, today we're going to talk about the working principle of a switch. Here we can see two PCs and a switch in the middle. In this context, the switch we're referring to is a layer 2 switch, which operates at the data link layer. It forwards data based on our MAC addresses, which is used for sending and receiving data. The interfaces of the switch are independent of each other, meaning each interface belongs to a different collision domain. This effectively isolates collision domains within the network. Additionally, the layer 2 switch continues to learn the source MAC addresses and from the data to maintain the correspondence between MAC addresses and interfaces. In this context, in the future, we will store this information in a table called the MAC address table. The MAC address table essentially contains the correspondence between interfaces and MAC addresses. If, in the future, our layer 2 switch to see a piece of data here, if it is to assist in forwarding in the future, it needs to be determined based on this MAC address table. From which interface should I send it out? At this point, we determine it based on the MAC address. For example, during this process, our data arrives. The source MAC address of the data is MAC 1, and the destination MAC address is MAC 2. Of course, in this context, we also have our IP address and the destination IP address. In this process, our layer 2 switch does not look at our source IP or destination IP, and of course, it also does not look at our data. Here, it only focuses on our source MAC and destination MAC. After I receive a piece of data, I will learn this MAC address and place it into my table. For example, if I now receive data from interface number 1 sent by someone else, for me at this moment, I am receiving data, but I will then record it in my table accordingly. In this process, for example, if the MAC address corresponding to our interface number 1 is MAC 1, it will be placed in my table, and I will record it in my table. Remember, at this time, learning occurs only during reception, not during sending, 对吧? So after I receive it, I will first record it in my table. Then, in the MAC address table, I will check who you want to send it to. If you want to send it to MAC 2 during this process. For example, if we have MAC 2 here, I will forward it based on my table. Suppose it is here, and my table has a record indicating that my interface number 2 corresponds to this MAC 2. Then I will achieve forwarding from this interface number 2 to help them communicate with each other. Each switch will maintain its own MAC address table to store the relationship between MAC addresses and switch interfaces. For example, in this case, I would record that interface number 1 corresponds to MAC 1, and interface number 2 corresponds to MAC 2, all stored in my table. In this context, when forwarding, my switch will look up the MAC address table based on the destination MAC of the data frame. If the MAC address table contains an entry corresponding to this destination MAC, then I will use the associated outgoing interface. To achieve forwarding, if my MAC address table does not have a corresponding record for the destination MAC, then I will send a copy to all interfaces except the one that received it. In other words, I will send a copy to all, and this action is called flooding. So, when do we perform forwarding? And when do we perform flooding? As well as the behavior of the switch in handling this. How many types are there? Let's take a look here. In this process, the switch actually has 3 types of processing behaviors for our data. Through these 3 processing behaviors, we handle the data frames here. If we say that the switch forwards through these transmission media, whether it's network cables or optical fibers, it processes each frame that enters the interface. There are 3 processing methods, which are flooding, forwarding, and discarding. Let's look at them one by one. First, flooding means that, like a flood, as soon as I receive it, I will copy and send a copy from all my remaining interfaces. For example, if it receives data from port 2, then apart from this port 2, I will copy and send a copy from my remaining ports 1, 3, and 4. What else is there in this context? Additionally, when our switch receives data from an interface, it forwards it uniquely to the corresponding interface. For example, in this case, I only send it to port 4. Did I send it to port 1? Did I send it to port 3? No, I only sent it to port 4. This is one-to-one forwarding. Besides this, there's also discarding, which means the switch discards the packet received from this interface. In other words, I don't perform any processing on it, and this is called discarding. First, let's take a look at when I would trigger the flooding action. If a data frame enters through our transmission medium, whether it's a network cable or fiber optic, into the switch's interface, the switch will check its own MAC address table for the destination MAC. If it can't find it in the table, it will broadcast this unicast frame. But remember, in this context, it's a unicast frame, meaning I am looking for the other party one-on-one. In this case, if it's not in my table, I will flood it out, meaning I will send a copy from all my remaining interfaces. However, if this data frame is not a unicast but a broadcast, then as it enters the switch interface, through our transmission medium, I will directly flood it. And it's not that I look for this destination in the MAC address table. I don't even look at the table. I just send it directly. Let's take a look here. If in this process, I have a unicast data frame, and my source address is MAC-1, and the destination address is MAC-2. This is called unicast, meaning I specifically want to find this MAC-2. In this process, I will look in my table to see if there is a route to this MAC-2. First, when I receive data, I will definitely put it in my record table, which means I will record the MAC address corresponding to my J001 in the MAC address table as 1. Then, it needs to go to this MAC-2. I look in my own table and find that there isn't one. So at this point, I will implement flooding, meaning I will send a copy from both this interface and that interface. Then, when 1.2 receives it in the future, it will reply. Once it replies, my switch will receive it in my MAC address table. For example, during this process, MAC-2, and then its interface is J002. When my PC1 goes to find PC2 again at this point, it doesn't need to flood anymore. It can directly forward. This means that if my MAC address table doesn't have a corresponding destination MAC, at this point I will flood. I want to find the other party more quickly and efficiently. Then there's another scenario, which is when my original MAC is 1 and the destination MAC is FFFF, all FS. In this process, this indicates that it is a broadcast frame. For a broadcast frame, at this point, we skip this step entirely, meaning it doesn't check the table at all and just sends directly. I directly copy and send a copy from the remaining interfaces. During this process, this is also referred to as flooding, meaning either this is an unknown unicast frame or it is a broadcast during this process. And at this time, we will flood. Here, everyone needs to pay attention. In this situation, our MAC address table will learn the corresponding relationship between MAC addresses and interfaces during this process. It will have an aging time, which means 5 minutes. Within 5 minutes, if there is still data flowing, I will refresh the aging time of my MAC address table. If within 5 minutes I do not receive data on this interface, then during this process, my MAC address table will age, meaning this entry might disappear from our address table. This is our general rule. If in the future everyone is working on a project, what might you encounter? You might encounter a forwarding situation. Under what circumstances will we forward? Here, let's say I have a single data packet, whether through a transmission medium like a network cable or fiber optic, entering our switch interface. Here, I will check the corresponding relationship between the MAC address and the interface, and then forward according to the MAC address. For example, during this process, we see that the source MAC address is 1 and our destination MAC is 2. Now, when it receives a packet, it will check its own MAC address table during this process. If it finds that its MAC address table contains this MAC2 and the corresponding relationship is J002, then, in this process, it will specifically send it to J002, and from J002 it will be sent to our host 2. This allows our host 2 to receive it, which is our forwarding process. In future projects, during this process, besides forwarding and flooding, there is a final action called discarding. So, when will discarding occur? It happens when a data frame enters through a network cable or fiber optic into the switch's interface. The switch will then check the destination MAC address of this frame in its MAC address table. If the corresponding entry is found in our MAC address table, it will check whether the data I want to send in the future should also be sent out from this interface. For instance, in this process, if my host 1 wants to find host 2, I send a unicast frame to switch 1. After our switch receives this unicast frame, if the destination MAC is not in the table, switch 1 will flood the data frame, meaning it will copy and send a copy from all remaining interfaces. In this case, if switch 2 has this MAC address in its table, after switch 2 receives it, it realizes that the interface corresponding to the destination MAC address is the one receiving this data. At this point, switch junior will discard this data, because during this process, it realizes that the data came this way, and in the future, when it needs to find it again, it will have to go out from here. Since you originally wanted to find this thing and came to me, now if I send it back to you, it will have to go out from this interface again. It might think, could this potentially cause a loop problem? In other words, you send it to me and I send it back to you. To avoid this situation, we simply directly discard this data. Now, during this process, we call this in and out the same way, which will result in a discard. Of course, if the data is being transmitted within our network. During this transmission process, our data encounters a bit of an issue on the way. Error in HCIE. At this time, it will also be directly discarded. These are the 3 forwarding modes of our switch. Now, let's take a look at how the switch learns. The MAC address table and the entire process of learning, including the forwarding process. Initially, we say that the switch actually does not know the MAC address of the host, so at the very beginning here, our MAC address table is actually empty. Now, if during this process a data packet is sent to our switch, for example, if host 1 wants to send data to host 2, let's assume that host 1 has already obtained the IP address and MAC address of host 2. Now, host 1 will use its own IP and original MAC to encapsulate this frame. When the switch receives the frame, it will search its MAC address table. If it cannot find a corresponding entry in the table, it will treat the frame as an unknown unicast frame. During this process, it will first record it here. It will say, oh, I understand now, I have learned an original MAC, because after all, I received a packet here. First, it will fill in the MAC address table here, saying, oh, I already know that the MAC address corresponding to port 001 is 1. Then, it will proceed to flood. In other words, it will copy and send a copy from the remaining interfaces because it is an unknown unicast frame. Since our MAC address table doesn't have it, the MAC address entries learned by the switch here are not always valid. Each entry has its own individual life cycle. If it is not updated within this life cycle, the entry will be deleted. This is what we previously referred to as the aging time, also known as the aging period. For Huawei S-series switches, the default time is 300 seconds, which is 5 minutes. During this process, we will wait. Wait for the switch to help us broadcast and see if anyone responds. If during this process, after we broadcast, all the computers in the local area network will actually receive this frame. However, only our PCR, which is our host 2, will process it because the destination MAC in this frame is the MAC address of the host. I know you are looking for me, so host 2 will respond to host E. The response here is a unicast, meaning I will unicast a reply to you. After the unicast response, in this situation, my switch will receive data from this interface. Once it receives data from this interface, it will also record it in my table, meaning it notes that, oh, I have now received data from 002. Originally, its MAC address is MAC2, which will be placed in my table E. During this process, after placing it in the table, I will then check who the destination MAC is for. It's for MAC1. Since previously PC1 sent a packet from here, I have already learned it in the MAC address table. At this point, my MAC address table contains it. So I will use my MAC address table to perform a forwarding. When I see that the destination MAC is 1, I need to forward it from the J00E1 interface. Perform a send. Now, within this setup, the switch can normally assist in facilitating communication between PC1 and PC2 en route. Moreover, if they continue to communicate within 5 minutes, it will maintain this setup. Then my ARP table will not age. However, if within 5 minutes they do not continue to access each other or no data passes through during this process, I will delete the corresponding MAC address table entry. For instance, if within 5 minutes I have not received any access from PC1 through this interface, whether it's this interface or that one. As long as I haven't, here at this interface, I receive the flow of data, and at this point I will delete the corresponding MAC entry from the MAC address table. This is because the switch uses the MAC address table to achieve forwarding. To help us with data communication, it has an aging time of 5 minutes, which everyone should know and understand. This means that if I receive an unknown for unicast frame, I will flood it. If I receive a broadcast frame, I will flood it directly without checking the MAC address table. For an unknown unicast frame, I will check the table, and if it's not there, I will flood it. I will flood it in this case, if in this situation I receive a unicast frame and I can find it in my MAC address table, then I will forward it. However, if I find that the data comes in from this interface and needs to go out from the same interface, this is called hairpinning, and the source of the loop. At this point, we will discard this data. Everyone should understand the forwarding principle and working mechanism of a switch, which essentially revolves around the MAC address table. This is the working principle of our Layer 2 switch. If anyone wants to learn Huawei certification technology or obtain the Huawei certification question bank, please send me a private message. You can also leave a comment below the video for technical exchanges. Ani, that's all for today.